In 6C, it wasn't very clear in your copy of your pre-take here, so I'm not sure if you saw this as an a to the negative 1/2, but that's what it is. There are a couple different avenues that you could go down, and I'm going to go down the path that I feel most comfortable with. When I see two like bases being multiplied together, I like to collect them up as just one base. So the first thing I'm going to do is I'm going to rewrite this as a to the 1/4 over, this is going to be 7 times, now I want to add my 3/5 and a negative 1/2. We multiply like bases, you add exponents, so it's 3/5 plus a negative 1/2. Or really what I have is a to the 1/4 all over 7 times a to the 3/5 minus 1/2, because it was a negative exponent down there. I can use, instead of plus a negative, I'm just making it negative. And now I'm going to rewrite it using a common denominator, a to the 1/4 over 7a, and the common denominator between 5 and 2 is 10, so 5 times 2 is 10, so 3 times 2 is 6, so I have 6 tenths, then minus, now I've got to multiply this times 5 to the 10, so 5 times 1 is 5, so 6 minus 1 is 5, or 6 minus 5 is 1. So I'm going to wrap this around over here, so now I have a to the 1/4 over 7 times a to the 1/10. So now what I'm going to do is I'm going to use our quotient rule, so when we divide like bases, we take our exponents and we subtract them. So I'm going to pull out the 1/7. Multiplying by 1/7 is the same thing as dividing by 7. I think it's just a little bit cleaner. And now I've got a to the 1/4, and I'm supposed to subtract 1/10. So before I can subtract, I have to get a common denominator, so the next step I'm going to be doing is getting a common denominator between 4 and 10. The least common denominator is 20, so 4 times 5 is 20, so I'm going to multiply both of those by 5. And 10 times 2, so I'm going to multiply both of those by 2, so it's going to be 5 minus 2. So this final step is just to add those or subtract those numbers, so I got 1/7 times a to the 3/20, and now I have it simplified as far as it will go.